Good morning, students. Now we come to the explanation on equilibrium notes I have already sent to you. Now let us discuss this equilibrium of coplanar forces. So what is the equilibrium of coplanar forces? So there is a theorem you see from the notes. If you have three coplanar forces mean forces acting on the same plane, acting on a rigid body, if all those three forces, say P, Q, R, are coplanar forces which are which are in equilibrium. So if all these forces are in equilibrium, then by this theorem they must either all three, means all these three forces meet at a point, like in this case P, Q, R, or they must be parallel to one another. So let us see here how they prove it. So if you have P, Q, R be forces acting on a rigid body which are in equilibrium, then we name these forces as P, Q, R. So suppose here let P and Q, forces P and Q meet at a point. P and Q here. Forces P and Q meet at a, okay, let me write here. This is force P and this is force Q. They meet at a point. Then by parallelogram of forces, which is in unit 1, their resultant, these two forces can be combined into a single resultant by parallelogram of forces. Parallelogram of forces. These two forces can be combined into a single resultant acting through this point. O is the point where these two forces P and Q meets. And then since you have three forces P, Q, R and two of them already meet at a point, and this is their resultant, I name it as P plus Q acting along this line, then R, which is a third force, must balance the resultant of these two. So this R must be acting in this direction along the same line of action but in opposite direction. If the resultant of these two forces P plus Q is acting in this direction, then R must balance the resultant of this and also acting along the same line must be in opposite direction. So therefore, thus these forces P and Q acting at a point, which is suppose if they meet at a point, their resultant is acting in this point, and the third force also is acting along the same line as a resultant of this. So as you can see in this figure, all these three forces P, Q, R, they meet at a point. So therefore it satisfies this. If three forces acting on a rigid body be in equilibrium, they either all three meet at a point. As you can see here, P, Q, if two of them meet at a point, then the third force R also must meet at a single point, at this common point where these two forces meet. Or else if two of them they are parallel, this is the condition when if two forces meet at a point. Now if they are parallel, suppose here P and Q are parallel forces. This is force P and this is force Q. They are called like parallel forces because they are acting in the same direction. Suppose they are like parallel forces, then their resultant will be also a parallel force is acting along this line P plus Q. And R balancing, and R, which is the third force, must balance the resultant of these two forces will act in this direction but in opposite, will act along the same line of action but in opposite direction. So therefore this R must balance the resultant of these two forces. So therefore, as you can see here now, forces P, Q and R, they are all parallel, or else they are parallel to one another. Or this is case when P and Q are like parallel forces. Now suppose P and Q they are unlike, one is in this direction and the other is in this direction. So they are unlike parallel forces P and Q, then their resultant, suppose the resultant of these two is acting in this direction. So the third force R, which balance the resultant of these two forces, the resultant of these two forces is here. So the third force R, which balance the resultant of this, must act along the same line of action but in opposite direction. So as you can see here, in both the cases, if they are like or unlike parallel forces, then all the three forces, they are parallel to one another. So this complete the proof. And note that P and Q cannot form a couple. By couple, we mean that P and Q, they are two equal, unlike parallel forces. P here is called Q, and because the force and a couple, there is a force and a couple, and the third force are here, which can be either in this direction, can never be in equilibrium. Okay, so therefore, these forces and a couple can never be in equilibrium. If P and Q form a couple, then the third force R cannot be in the third force R. It can be parallel to one of this, but they doesn't keep the body in equilibrium. Equilibrium means the body is at rest, or it is moving with a uniform speed. And when the forces also, the above theorem gives us only the necessary condition but not the sufficient condition. And when the three forces meet, they must satisfy the Lami's theorem, or the converse of the triangle of forces. That one, they are in unit 1 only, Lami's theorem. So now let us see one problems related to this equilibrium of forces, how to show that whether the given forces is meet at a point, or they mid at a point means they are either mid at a point or they are parallel to one another. So here you have your forces 3, 4, 5 gives a body in equilibrium. Draw a diagram to show their line of action. So here these are the forces 3, 4, 5. They are forces which keeps the body in equilibrium. So it means that all three forces must be parallel, or they must be, or else they meet at a point. So we'll check whether they meet at a point or they are parallel. So for that we have to draw a diagram. So if a body is in equilibrium, as you know from the theorem, forces 3, 4, 5, they must be either meet at a point or are parallel to one another. But here the forces are not parallel. The forces 3, 4, 5 are not parallel, because the sum or the difference of any two, you take 5 minus 4 gives you 1, which is not equal to the third force. Or if you take 3 plus 5, also the sum of any two of these forces, it is not equal to the third force, means 3 plus 4 is not equal to 5. So therefore here 3, 4, 5 are not parallel, since the sum or difference of any two is not equal to the third force. So therefore the only possibility, because these three forces keeps the body in equilibrium, the only possibility is that they all three meet at a point. So 3, 4, 5 forces 3, 4, 5 meet at a point. And here each force is equal and opposite to the resultant of the other two. So if you take, and from here you take, we know that 5 square is equal to 3 square plus 4 square. So if this is satisfied, it means that the three forces, so all the three forces meet at a point. So if they meet at a point, and from the given forces, the magnitude of the forces, we have 5 square is called 3 square. So therefore the forces are at right angle, the forces 3 and 4. The forces 3 and 4, they are right angle to each other. So therefore you can write this is force 3 and this is force 4, which is at right angle, because the sum of the square of these two, forces is equal to 5 square, that is the third force. So therefore the resultant of these two, which is acting in this along this direction, that is 3 plus 4, must balance, that is 3 square plus 4 square, or you can say that the resultant of these two, that is P plus 3 plus 4, must balance the that is the third force R here must balance the resultant of these two forces, and we denote it by 5 here because the third force is 5. Hence they must this 5 force R or force 5 must balance the resultant of these two forces, and it acts along the same line of action but in opposite directions. That is, if the resultant of this is acting in this direction, then the force 5, that is the third force, must be in this direction. So therefore, let O here be the meeting point of these two forces, and we denote it if you draw a right angle this xy coordinate. So these are the forces here. This name it as B, O, A, B, C. So as you can see here, the forces 3, 4, they meet at a point, and the third force also, that is force 5, is also meeting at this point also. Therefore, forces 3, 4, 5 keeps the body in equilibrium, since they cannot be parallel as we have mentioned here, because these forces are not parallel, since the sum or the difference of the two is not equal to the third forces. So this proof the theorem, and the diagram is this one. Okay, I hope it is clear to you. So the next problem I'll discuss one or two more problems I'll discuss from this equilibrium of forces or coplanar forces. After that, we can start with the center of gravity.